Y'all can see my screen, right? කට්ටියටම ස්ක්‍රීන් එක පේනවනේ.
ඔව් ඒ පේනවා.
right. මේ අනිත් කට්ටියත් මොනාරි ඔයගලන්ට අහන්න තියෙන ප්‍රශ්න ඒ කියන්නේ ඩිස්කස් කරන්න කැමති පාස් ඒ කියන්නේ පාස් PP පාස් ප්‍රෝග්‍රෑමින් ප්‍රොබ්ලම්ස් තියෙනවා නම් මට chat එකේ message එකක් දාන්න මම පුළුවන් වෙලා ඩිස්කස් කරන්න. yes. Hi everyone. So before I start, just like to remind you to put any questions that you all would like me to discuss, any topics that you would like me to discuss in the chat or through either WhatsApp or on our group. So because then I can do a better better on explanation for you guys, better session for you guys. A few of you all have requested like certain things like mainly recursion. So I will go through recursion and how we can use it, practical applications, and few had asked like certain functions, like how to use the map function, how to use the complement function, so stuff like that. if any of you all have any doubts, just drop the message in the chat and I will explain. So, yes. Also, any Tamil speaking people here? Just raise your hands. Anyone who doesn't understand Sinhala. So anyways, I may use a few Sinhala terms here and there. So if you don't understand anything, just feel free to just drop a message and I will explain it to you even after the session. චැනුල් මේ වේටිං රූම් එක අයින් කරන්න පුළුවන්ද? Hi everyone. So it's 11. We'll wait about 5 to 10 minutes for everyone to join and then let's start. So in the meantime, if anyone has any questions, any topics that you would like me to discuss, please drop it in the chat. Uh, uh, so someone has asked, I can't use functions. Yes, okay, I will explain how you can use functions. Uh, I'll just give you a few examples of how to use functions. So if you can just uh, specify like where like you got stuck, like why you are having issues with functions, then I can give a better understanding. Yes, recursion. Anyways, I will be discussing. A lot of people had asked that. It's a tricky topic. I will definitely explain recursion. Don't worry. Any other topics that you all would like? Okay, so I've also got a few more, few more questions about how to approach matrix-related problems. Yes, that is something that we should discuss, a tricky part. There are some tricks that I used to use, which can be helpful. Which sort of algorithms we need to memorize and use in programs? Uh, uh, which sort of algorithms? In case of sort algorithms, do we need to memorize and use it in programs? Okay, I will go through sorting maybe today if we have time. If not, we'll do another session and go through sorting because that is a bit of an extensive thing to explain. So I have a few videos which I used which were helpful to understand the sorting algorithm. So I will send you those. And once you all get an idea through that, I think it's best for me to explain sorting in another session. So we'll do it like that. Enumerate. Yes, I will explain enumerate. Can you explain lambda functions? Yes. I will explain how lambda functions work. Don't worry. Okay, yes, recursive functions. I just had one. Yeah, recursive functions. I think I'll start with recursive functions because everyone wants that. So just give. We'll start in 2 minutes. Okay. So hi everyone. I hope we are live. Is this is being recorded, right? Channel. So again, welcome to this small Kuppi session that we have, which I will be going through some difficult topics that you guys have had in programming fundamentals.
Recording in progress.
So if you have any more questions, just feel free to add it in the chat and I will explain. If you have a bit of, if you feel like I went over something too fast, again, just drop me a message on the chat and I will explain it once again. Uh, and I would really like to get you guys input while I'm doing this session so I can do a better session for you guys. So if I ask a question, feel free to either unmute your mic and ask me a question or answer, or even drop a message in the chat. So at any time, if you all want, you all can drop a message in the chat. And if I ask a question again, you can unmute and ask me any questions that you'll answer, or ask me any questions that you'll want. Okay, so now we'll start our session with one of the uh, we'll start with one of the most requested topics from all of you guys, which is recursion. So I think recursion is something that a lot of you find difficult, which is understandable. It is a very different way of looking at problems. It's not very intuitive in the sense that it doesn't come to your head like as soon as you think about it. But recursion is done naturally in so many different parts of like our life, with be it in code or even outside code. There are many problems that we solve recursively in our day-to-day life. So recursion may not initially come to your head, but once you understand it properly, once you get the idea of what recursion is, it will be very easy for you. And also you'll like using recursion, because that's what happened to me. Once I understood how recursion is, I really liked using recursion even for the easiest problems, because recursion is a very elegant way of solving a problem. You can write very simple, easy to understand code using recursion. So it's just about understanding the concept of recursion. So uh, let me ask you guys a question. Does anyone have any idea of where recursion is used? Like any questions that any problems that we can use recursion to solve? Maybe in code, which you all have encountered, or maybe in day-to-day life. Anyone has any ideas? Can you please drop a message in the chat? Where do we, what sort of problems do we use recursion to solve? Just give you a minute. Just quickly drop a message in the chat. Even if you, I don't mind, even if you look it up on ChatGPT, just any specific problems that we use recursion and solve. Any answers? Finding the determinant of a matrix. Yes, that's a very good answer. Finding the determinant is where we use recursion. Yes. Any other? That's a very famous example. I think you all would have got this in your lecture notes as well. Find the determinant is one example, because you have to, if you're given a big matrix, you can't just say the matrix is, the determinant is this. You have to first find of a small, like if it's a 4 by 4 matrix, you find the determinant of the 3 by 3 matrix, then you find the determinant of the 2 by 2 matrix. And then only you can say, okay, these combined is the determinant of the 4 by 4 matrix. So yes, you divide the problem into smaller parts. You keep going inside recursively and solve the matrix problem. Okay, what else? Yes, finding factorial. That is the most common, finding the factorials. One of the most common questions where we use recursive functions, because the factorial is just, let's think the factorial of 5 is 5 multiplied by the factorial of 4. So you keep going into this, you make the factorial of 5 by combining the smaller factorials. So yes, that's a one common example. The other one is finding the Fibonacci number. Very, very common example. Because Fibonacci also, it's comprised of, let's think we have Fibonacci number n. It's the sum of the n minus 1th Fibonacci number and the n minus 2th Fibonacci number. So you can see that we recursively call these we recursively calculate this Fibonacci number by first we first find the smaller numbers, we combine it and find a larger number. So so these are all software problems, right? Like, stuff we do using software, like code that we write just to make things easier. While but one of the examples, which is the determinant of the matrix, is even if you are going to manually calculate the determinant, you have to do it recursively. So can someone give like a real life example, like in your like in our environment, like not through code, something that's less technical? Can someone talk about like a recursive uh, finding permutations and combinations? Yes, I think finding permutations could be recursively done. Yes, that is uh, that can be recursively done. A bit tough, but it is recursively done. You are correct. So, okay, so I think that's it. But when I was thinking about recursion, one of the I was thinking about like examples for recursion in our day-to-day life. And one of the things that came into my mind when I was thinking about it yesterday is the election. So I think everyone is, buzzed up, excited, and, looking to see what the results of this election are. But when you think about it, the election is also, the votes are calculated for the election kind of recursively, right? So for example, you take Sri Lanka, right? So we want to find the president of Sri Lanka. We want to see what the people of Sri Lanka, who the people of Sri Lanka want as the president. But if you're going to ask each and every person in Sri Lanka, who do you want for president? Who do you want for president? Right? It's going to be difficult, right? You can't really, the logistics, the getting everyone to one place, it will be a huge pain. So because of that, what we do is we break Sri Lanka into smaller parts and we ask the smaller parts, who do you want as president? Right? So that's what we have done. We divided Sri Lanka into provinces and we asked the provinces, who do you want as president? So again, a province is pretty big. So again, it would be quite difficult for us to ask each and every person in the province, like getting everyone to one place in the province, and doing that would be difficult. Doing the calculations would be kind of difficult because there's about 1 million in some provinces. There's 1 million, 2 million. So again, difficult. So then we divide it even more, and then we ask district wise. So who do you think is the president? Who do you want for president? But still it's more difficult. So we break it down some more. So we break it down into what do you call it? Divisional secretariats, then it goes down to Gram Niladhari divisions, and so on. And finally, we come to the small polling booth, which has, I don't know, maybe about 1,000 people per polling booth. So something like that. So we divide this big problem, which is who does Sri Lanka want as the president? We divide it into smaller parts, right? Small parts. And then we ask the small part, what do you want? Who is your president, right? And then finally, after we get the answer from the small part, so let's think you take your polling booth. You can even divide the polling booth into smaller problems, which is each individual person, right? So that is let's say the base case. The base case is who does one person want as a president? So you take the base case, which you have come across by dividing the big problem into small parts. So we have the big problem, which is who is the president of Sri Lanka, and we divided it into small parts. And the smallest part, which is who do you want? Who does one individual person want as a president of Sri Lanka? And once you get the answer for the base case, what you do is you combine all these base cases together. So, for example, like let's think I want A as the president of Sri Lanka and someone else wants B. So we combine. So in the polling booth, what we do is we combine all the answers for each individual person and we get an answer. So this many people want A, this many people want B, and this many people want C. Next, what we do is so the polling booth we got the polling booth as a division of a bigger problem, which is, let's say, the district. So then to find the answer for the district, what we do is we sum up the answers we got from the smaller divisions, which was the polling booth. So then you have the answer for the district. And then similarly, you do it for the province. And finally, you get the answer for the big problem. So I hope everyone understood how I took this example of our presidential election that we just had recently. And showed you that even the presidential election is calculated on a recursive basis. So if anyone would like me to explain, clarify any parts again, just let me know. But you can understand that what we have done is we've broken the big problem into smaller parts and broken it into as small parts as possible. So that it's very easy for us to get an answer. And then what we've done is build the answer of the big question from the small answers that we've got. So we make we find the individual person. So this is exactly what we do for recursion. Recursion is breaking a problem into smaller parts, a big problem, which is difficult to calculate by itself. We break that big problem into smaller parts. And next, what we do is we sum up all of the parts or all of the answers that we got for the smaller part in order to come up to the answer we have for come up with the answer for the big question. So I hope you understood a very high level idea. So this is like the concept or like the idea behind recursion. So I hope this example helps you understand what we do in recursion. So yes, so now we'll go to how we apply this, right? So for example, let's take uh, finding the factorial, right? So I can write. You can't see my screen, right? So let's see. Can everyone see my screen? So yes. I think this should give the what have I done? Five isn't. Yes. Okay. So can you see how I wrote the iterative way of getting the factorial, right? So what I do is the factorial is calculated as a multiplication of all the numbers up to that number. So the nth factorial is the multiplication of all the numbers from 1 to 5. So I calculated the fifth factorial by uh, multiplying by iterating from 1 to 5. And then I multiply I have the factorial set as 1. And I multiply uh, each iteration, I multiply the factorial by that number. So 1 gets multiplied, 2 gets multiplied, 3 gets multiplied, 4 gets multiplied, and 5 gets multiplied. And you have the factorial. But now let's think how we can do this recursively, right? So I think if you're going to do a question recursively, we have to think of how we are going to divide this problem, right? So let's think about that. Can someone drop a message? Can you all drop a message about uh, how we are going to break this factorial into a smaller sub problems? How is the factorial built up, right? So it's like you have to, let's think you have the big problem. We break it down into a sum of smaller problems, or maybe we build it up by using the smaller problem. So let's think the factorial of 5. What's the smaller problem we can, that the factorial of 5 is built up from? And someone dropped a message in the chat. Yes. So I think you understand that the factorial of 5, to make the factorial of 5, you need the factorial of 4. So the factorial of 5 is 5 multiplied by the factorial of 4. So now we have an idea how this factorial of 5 is divided into a smaller problem. So now we can write it, we can kind of make a small assumption that I'm just writing this as a note. So this is not code. Fact 5 equals 5 into fact 4, isn't it? So then we can write a general example, which is fact n is n into factorial n minus 1. So now you have an idea, right? How this big subproblem is comprised of. And now what you'll do is just code it. So, but before we code it, we have to have another thing that we have to clarify. So for example, you have to clarify two things when you're getting into trying to solve a problem recursively. The first thing is how this big question is broken up into smaller questions. And the other thing is what is the base case? Where do we stop? Because if you go recursively, keep on going into smaller problems, you're going to come to, you're not going to end. You're going to keep on going. So that is what we call the base case. The base case is very important to make sure that you get an answer at the end of the recursion. So what are the steps that we follow when solving a problem recursively? First, we find the smaller subproblems that we can divide this into. Next, we find the base case, which is where our recursion will end. So for example, for factorials, it will end at 1 because you can't go for a factorial smaller than 1. So we can say when we come to factorial 1, we know the answer, which is 1. So that is the base case. So for example, can someone say in the example that I gave with regards to the elections, what was the base case? So I don't know how the autocomplete figured out what I was saying, but it gave me the answer. But yes, factorial 1 is 1 was automatically typed. But yeah. Can someone give me tell me what was the base case of the election example that I used? Anyone? Okay, yes. So the base case of the election example was the preference of one single person, because you can't divide the problem anymore. So when you're doing recursion, first you find the problem. First you have the problem, you find how you can divide this problem into smaller subproblems. And then you come to the base case. Then next you find the base case, which is where you can't divide the problem anymore. So for example, for factorial, the base case is where you can't divide the subproblem anymore. So now let's code this recursive factorial, which is n. Now, I'm not going to use these autocompletes because, and I recommend that you also don't use autocompletes because it will not be useful for you when you're coding. It will, so at least for the first sem, don't use autocompletes. Just do it on the basic Python uh, do it on the basic Python, what do you call that? What is it? The basic Python notebook. So don't use VS Code, use it on idle. Do it on idle. So what we do is first, when we are going to write the recursive code, first we code the base case. If n is equal to 1, we would say return 1. So now we have coded our base case. So next, what we should do is we should figure out how these base cases combine to form the bigger subproblem. So in the example of factorial, it is we multiply n by the smaller factorial, by the smaller subproblem. So we multiply n with n minus 1. So that is how you get uh, the combination of the smaller subproblems to get the bigger problem. So I think now you have an understanding of how we get a recursive solution. So now I think this should give the right answer, which is, yes, it gives us the right answer. So does everyone understand the steps we can use and how we can combine these smaller subproblems to make the bigger problem, make the answer for the bigger problem? So did everyone understand, or would you like me to explain a bit more with another example? Can you all raise your hands if anyone would like me to explain with another example? Is there anyone? තව තව example එකක් use කරලා මේ ප්‍රශ්නේ explain කරන්න කැමති ඒ කියන්නේ explain කරන්න අවශ්‍ය කවුරු හරි ඉන්නවා නම් පොඩ්ඩක් අත උස්සන්න එතකොට මම explain කරන්න. Yeah. And so I'm assuming that everyone understood. Okay. So with the determinant of the matrix, if I go to do this with the determinant of the matrix, this will take a bit of time because I have to format the input and all of that. Shall we do it with Fibonacci series? I will explain the thinking pattern behind. Let's think. I feel like I should be able to. So shouldn't be an issue. So we'll see. So let's think the Fibonacci series. So you all know how let's say fib n equals fib n minus 1 plus n minus 2. So that is how the subproblem is divided and how it is combined to form the bigger problem, to find the answer for the bigger problem. So what's the base case for this Fibonacci problem? Can someone tell me the base case? Anyone? Can someone tell me the base case for Fibonacci? Yes. So here you can see we need two base cases because we are using two smaller subproblems. So we need Fibonacci 1 and Fibonacci 2, which are both equal to 1. So that is our base case. Fib 1 is equal to 1. Fib 2 is equal to 1. So now we have the base case and how the problem is divided. So now let's start with coding this Fibonacci problem. So what we should do is first code the base case. So the base case is if n is equal to 1 or if n is equal to 2, the answer is 1. So the answer that Fibonacci 1 or Fibonacci 2 will return is 1. So let's code the base case. base case is if n is equal to 1 or n is equal to 2, we return 1. So next we code the return value if n is not equal to any of these numbers, which is if n is greater than 1. So since we catch n is 1 or n is 2, we don't have to put a if statement. But if there is a possibility that it can go to negative numbers, we have to put it in an if statement. But here we can just put return fib n is for fib n, we return fib n minus 1 and n minus 2. So now you all understand how this uh, recursive, what do you call, how the recursive method is formulated, how the steps we use to come up with a recursive solution. So I will briefly explain how uh, a matrix calculation is also done. Yes, so when we have this matrix, how do we divide a matrix to find the determinant? We first take the determinant of these four. Then we take the determinant of 2, 3, 5, 6. We take the determinant of these four, take the determinant of this, and then we do, how do you do that? Yes, we multiply. I will explain how to do it maybe in the next session, the determinant way. But again, it's dividing it into smaller sub problems and finding the answer. So I also can't remember this finding the determinant, the mathematical formula. So I will just go through that and explain it to you in the next session. Uh, so just give me 1 minute. So any questions regarding recursion? So I think I went through Fibonacci as well as the factorial problem. So does anyone have any questions? Hmm. Are there any questions regarding recursion? Or if you all have any problems that you all uh, did you all thought of doing using recursion, just let me know. Uh, any clarifications, anything like anyone wants to do another example? Any questions that you all felt that we could do using recursion but weren't sure how you could do it? Yes. Can Yes. So one guy has asked, let me put this message uh, uh, on the chat. So one person has asked, I remember sir telling us that recursive codes are very expensive in terms of memory. So that is a good question, because recursive code is kind of expensive when you're using memory, because it when you have this function, you call another function inside. So these function values, the variables, have to be saved somewhere. So when you're saving this, every function you go into, you're making the memory that you need for this function much bigger, because you're saving this function values, the function variables. You have to save it. So uh, because of that, uh, we have to be careful when you're using recursion, we have certain methods which are advanced, which we use to solve this memory issue. It's called like memoization, dynamic programming, stuff like that are used, but it's outside your scope, right? So yes, recursion has will give you memory issues, and most of the time, stuff like Fibonacci, which can be done without recursive techniques, you should do using the iterative techniques. But there are some problems which are difficult to do using these iterative techniques. So because of that, then we have to use recursion. So I think uh, uh, yes, someone has asked how to identify whether we should do it recursively or uh, whether we can do it iteratively. So I think the best solution for this is, I think even in your PP1s, most of the questions you can do iteratively. You will very rarely get recursive problems. So most of the time, I think go for the iterative solution. If I think if it's something which is difficult, like for example, uh, if now factorial or Fibonacci, you can see you can do it iteratively. But some questions like which you have to divide the subproblem many times. For example, like a merge sort, where you where if you draw the tree, like how the subproblem which you have is divided in like 4 5 aspects, 4 5 parts, then your iterative solution is going to be difficult, right? So, for example, factorial, uh, you divide it only once, right? Each problem gets divided once. Even Fibonacci, it gets divided twice, but you can do it iteratively, so that is divided only once. So uh, because of that, I think always just think, if is this is this big problem divided into many sub problems. If it's divided into many sub problems, then we should use a recursive solution. If not, always go for an iterative solution. So uh, can any someone has asked, okay, are there any step limits for recursion as well? Yes, the step limits is your recursion is limited by how much memory you have, right? If you run out of memory and you can't save the new recursive function that you want to save, then you're going to you may have encountered, you will come across this stack tracer. Let's see uh, if we can come up with this. Yes. Okay. See, you get this recursion error. Can everyone see my screen? Maximum recursion depth exceeded. So when I remove the base case, it keeps going. It keeps going to the negative values. It keeps going to, like, it will go to like minus 1,000, even minus 1,000, minus 1 million. So because of that, that's the importance of having a base case. You will exceed the limit of memory you have in your device to store these recursive functions if you don't add the base case. So yes, there is a limit, and the limit is how much memory you have in your we call it the stack, which stores the function values. So how much memory you have in your stack to store these recursive functions is the limit you have for recursion. So now you can see when I put the base case, you don't have this issue. But when I remove the base case, you have this recursion error, right? So hopefully that answers your question. Mm, yes. Any recursive problem, can any recursive problem turn into iterative form? So that's also a good question. Can any recursive problem be turned into an iterative form? So I also had this question when I was doing recursion, and at first I thought it's not possible, but I think almost any recursive problem can be turned into an iterative form if you do it, but some problems will be very difficult, right? For example, like if you try to do the merge sort, it's a bit challenging because merge sort you do it recursively, but if you're trying to do it iteratively, it can be a bit challenging, and you'll have to use like while loops. You'll have to check properly how this happens. It will be like a bit of a pain. So yes, you can do any recursive function problem iteratively, but the code will look very ugly. It will be very bloated, right? So I think that's the answer for that. Yes, someone has said there's a way of calculating the determinant. Can you tell how to do this recursively? Yes. Shall we keep this till the end of the session? We'll do this at the end. Uh, and because then the people who want to go more into depth into this recursion, we can stay after this session and we can discuss that. And even the super digit sum, uh, we'll do this after. So because I want to give you all an understanding about PP1 as well, like give you all a few tips that you all can use when doing your PP1. So because of that, we'll leave recursion for a bit because I think I explained with a few examples how this recursion happens, and we'll move on to uh, PP1, like not PP1, sorry, PP2 questions that you all can solve, right? So, so before, yes, exactly. Yeah, you all are going for PP2. So can anyone, can you guys tell me what were the problems you all had in PP1? Just drop a message. What are the problems that you all encountered during PP1? Time constraint. Oh, spiral matrix. Spiral matrix. I remember this spiral matrix question. That was kind of tough. So I think I came up with a solution for this. I'll try to send it on the group. The spiral matrix actually was a bit of a tough question. I think that really missed a lot of people. Uh, yeah. But yes, spiral matrix, anti-diagonal of a matrix. Yes, so I think even I remember, if I remember correctly, I think I did this spiral matrix recursively. If I'm not mistaken, I think I did it recursively. So I'll try to find the solution that I did. Uh, and um, yes, so I think a problem that most of you all are having is uh, uh, the problem most of you guys are having in this programming problem is how to manage your time. Like, because we have a very limited amount of time, and but still we are expected to do quite a lot from that time, right? So understandably, a lot of people are struggling in that aspect. How do you manage your time in PP1? So uh, let's go through like the steps that I used when I was doing this PP1. Does anyone have like a question that you all would like me to do here uh, in the session? Are there any questions? If you can, just can you drop the question in the our WhatsApp group so that everyone can see? And let's just try to, I'll just try to do a question so you all can see how I do it. Maybe it will take me more than 30 minutes because I haven't coded in Python in a while. I've like once you come to CS, you have to code in like uh, I we current these days we code in like C++. So because of that, I haven't coded in Python in a while. But if you all have a question, shall we do that? Turning a matrix by 60 degree, by 90 degrees by given n times. Okay, that I think that's a fair enough question. Uh, so shall we try that then? Turning a matrix by 90 degrees a given amount of time. So okay, let's see. This is an interesting question. It might take me a bit longer than 30 minutes, but let's see. So let's take in the input. Equals X. Let's take, for example, this 4 by 4 matrix, right? Uh, I think usually how you all will get this is, so what you will get is, uh, you get the dimensions of the matrix, which would be like n times. Most of the time you would get a square matrix. So let's say n is equal to 4, right? And remember, all your inputs are strings. Okay. So I'm doing this. I will I can see people have questions, but first we'll try to do this question, right? As a think of this as a programming problem which you get for PP2, and that is you get an input like this, and let's make this into a string and see. How do I do this? So I'm just trying to structure this so that we can do it like a programming problem. Okay, does that work? Right. Yes. So your input will be something like this, which will be comma separated. Uh, so each row will be a comma separated string, which has will be something like this, because yeah, just have to understand that uh, be like this. So yes. So even if it's you have to figure out like how uh, we have to figure out how to take these inputs first, right? So let's see. Yeah, I think it's better to structure it this way. Sorry. So this is the input that we are going to take, right? And so first step would be, so now, okay, this is our input, right? So now this is our programming problem. Uh, so my first step when I was doing these programming problems was I would first take the input. First, I would read the question. So they would give you like a long description, right? This is what you have to do. This is what you have to do. Then sometimes I don't like. There's a lot of words, right? There's so so many words. When you're reading through that with little time, you don't understand. So what I would do is first read through that once slowly, and then if I understand, have that idea, and I go to the example. I go to the example and try to figure out, okay, input is this, output is this. So this is what they want. And then again, once again, read the problem statement, right? And then I have an idea. Maybe I don't have the steps or the solution for the algorithm, but I have an idea of the type of input and the type of output. So what I would do initially, before first I would think, okay, a few seconds, I would think, do I have an idea solution? If I don't, I would still quickly start trying to take the input because that also takes some time. So I would start, let's think in in let's say n equals input input and take the input. Yeah. Uh, And so it would be n equals int uh, n. So again, it will be a bit different in when you are doing your exam, but it will be something like this. So then I would say print n to just to check, right? I would always remind you every step that you do, put a print statement and check if you're doing it correct. When you're taking the input, put a print statement, check if it's correct, because that will save you time at the beginning. Like although putting the print statement may take you like 2 seconds, it will save you like a lot more time that checking and verifying your code at this stage than checking it later on when you coded the whole solution. So I take in, I check the input. Then for I in range n, I would do is uh, print matrix 4 by 4. I'll just change this to matrix I. So I'm checking, like I'm for you it would be something like print input like this, but from me it will be this. So I'm checking, okay, am I taking the input? Uh, but looks like I am not. There's an issue here. What's the issue? Okay. So see, okay, now it's getting printed. So I can remove this statement. And now we can see that, okay, now I'm getting row by row and I'm printing it. So next, my question is, okay, now these are strings though. I'm getting a string. How do I divide this string into numbers? So let's take an example called row. We save this is matrix I by I, and we print the row. So we save it, we save the row. Now you can see we are printing the row. Now I want to divide this row into a list of, I'm going to divide this row into a list of strings. So for that, I think you all may have used the split function, and we split by the comma and the space. So now you can see it's nicely split. The row is split into strings of numbers. So you can see it's a list of uh, number strings, right? So now I've I've gotten the input, right? The last thing is converting this into integers. So I think someone also asked me about the map function. So I will explain a bit about the map function while I'm doing this, because it will be really helpful for you to use this map function. This map function is like a cheat code, because if you are going to manually try to convert this into string, it would be something like for I in row uh, or I in, sorry, in range len row I equals int row I. So this would be like the manual way of iterating through the what we have to do here is every value in this row list, we have to convert it into an integer. So if you are going to manually do this, it would take a long time because we have to iterate every single value in this row, and then we have to convert it and then put it back. So this is a bit of a hassle, right? So because of that, we have a small cheat code that we can use, which is called the map function. So what the map function does is this exact same thing, but with just one line of code. So what the map function does is, so let's think we say new row equals list equals map. So what we are going to do is we have something that we need to iterate over. And we need to do a certain function. We need to do a certain transformation or a function on every single item of this iterable list. So for example, we have this row, right? We have to iterate over the row and we have to convert each item into an integer. So again, we have something that we have to iterate over. And when we iterate over it, we have to do a certain transformation for every item of that thing we are iterating. So that is the problem that we are having here. So that is what map does. We input the function that we have to do, the transformation that we have to do, and the thing that we have to iterate over. So those are the two values that we pass into map. The function that we have to do and the full object that we have to iterate over. So first we pass in the function, which is the int function. We have to convert everything into int, and we pass in the thing that we are iterating over, the object, so which is the row. So we have to iterate over row, and for every item of row, we do the int function, which is, so now you can see we print new row. I think this should work. Yes. So now what map returns, one thing you have to remember is what map returns is a map object, right? So map does the thing. It does what it has done what it has to do, but it returns a map function, the map object, sorry. So because of that, we have to convert it into a list. So here, now you can see everything has been converted. And now we have a nice, how do I say it? We have a nice, we have a nice looking input. We have converted input into the format that we want. So next we are coming to the problem, the actual problem. So now I think it took me about, let's say, took me about 10 minutes, but that was because I was explaining it to you guys as well. So we took the input. So I think within about five minutes, you should be able to take the inputs, even lesser if you have practiced many times. So practice taking the input, practice, what do you call, practice splitting this string, practice this map function, and so when you practice all of that, and also practice putting print statements and checking your code. So practice those things, and then within like 2 minutes, you should be able to take the input, right? So next, we are going to come to the actual problem here, which is how we are going to rotate this. So for example, this 1, 2, 3, 4 should, let's think we rotate it once. So it should be here. 1, 2, 3, 4 should be here. So now we are going to come to the problem. How are we going to rotate this? So let me think. Hmm. So I think for me, in my head, what I'm thinking is if I have a function that rotates this matrix one time, right? So the question that the guy has asked is, the question that is asked is how to turn a matrix 90 degrees by given amount of n times, right? So if we are going to pass in like the number of times and rotate the matrix, it's going to be a bit complicated. So my solution for this is, what if we have a function that rotates this matrix one time, and we call this function n number of times? So I think that should solve our question. And also, I think I forgot to turns is number of two, so we'll just hard code that. Or just for sake of doing it, we'll do it like this. Turns is in turns, so um, right. So I think that's the way we have to go with this. We uh, make a function that rotates the matrix this many times, and then we call that we call that function n number of times. So let's take this definition. Let matrix. Okay, I'm going to turn off Copilot for a bit. Okay. So again, I'm reminding you guys, although I'm using uh, GitHub Copilot, don't use it when you guys are coding, because it will severely uh, mess up with how you all learn Python, right? So let's take the matrix in, and now I'm making this function. We'll also take in n, right? Which is the size of the matrix. And for now, we'll just for uh, row in matrix print row, right? So what I'm doing is, so yes, I forgot to do that. Mat equals matrix dot append new row. And okay, so now only actually I'm coming to save in the matrix. And finally, print met. Let's see. Yes, so you can see I've saved the matrix, and now we'll uh, do this rotate function once, and we'll see what happens. Int rotate. Sorry. So you can see it prints properly. So now that works. So now we have to figure out how to rotate this. And for this question, we'll take it as rotating it clockwise. So this part should be in this corner, right? So let's think about it. Would a transpose work? First question, like I'm just thinking out loud, like what's going on in my head. I'm just saying it to you guys. Would a transpose work here? Transpose would bring this here, and transpose would not properly work. But think of it like this. Now, if a transpose will bring 1, 2, 3, 4 here, but what we actually need is 1, 2, 3, 4 here. So maybe we can reverse the transpose and get an answer. So, but let's verify it with the rest. Transpose would bring 5, 6, 7, 8 here, but we need 5, 6, 7, 8 here. So that's interesting, right? If we can transpose this matrix and reverse the rows, then we would get an answer, right? Uh, do you all agree with that? Can anyone tell me if I'm wrong? If we transpose this matrix and flip the rows, then we would get an answer. So can anyone who agrees or disagrees just drop a message in the chat? how we are going to rotate this is we are going to transpose it and flip it, right? Can anyone agree or maybe raise their hands? That's the answer. Yes. So that's a good. So I think this approach would be correct. So now let's try to transpose the matrix. The transposing itself is an entirely different process, but there is a bit of a shortcut that we can use when we are transposing as well, which I want to explain to you guys here, right? So a lot of people ask me how we can are there any ways to transpose a matrix easily, right? Because otherwise, individually iterating the columns, the rows, and then making a different transpose matrix, it's very troublesome, right? So, and someone also asked me this exact function which I'm going to use to transpose the matrix. And now I'm going to use that now here, and I will show you how it works, right? So first, this function that we use is this zip function, right? So we can use this zip function and let's see what happens in this zip function. I think it will crash because no, no, that's not how it works. Mm. So uh, it should be okay. It's not okay. So yes, I will try to figure out how to do this. So this zip function, if you go, I think best is to go to these Geeks for Geeks and just have a look, right? Uh, this zip function, it combines different iterables together. So let's think you have two lists of length uh, 5. So if you give in two lists to the zip function, it will combine uh, each element and it will give you new lists, but these will you'll get 5 lists. So you give in two lists, but you get 5 lists where the two elements are combined. So let me see. Uh, So yes, how now I remember figured out how to do this. You have to give each element. So you may have learned this. This is to give all the elements, all the iterables in this matrix. So when I give it like this, I will get a different sort of list. So can you see? It's very easy, right? To when you unzip it, you just get the transpose matrix. See? So what I'm doing is so this is a print matrix, right? So I will show you how this works. Yeah. So this is our input, right? Uh, you, you can see this is the input, but this is the output of this zip matrix, right? So what does zip do? So what it does is when we go to this, what do you call line, what it does is zip with this star matrix, what we do is we pass into zip each row. Individually, we pass in each row. We don't pass in like matrix as an object. We pass in each row, right? So we pass in this, and this separately into zip, right? So what zip does is it runs an iterator and it combines each element. So it combines the 0th element, it combines the first element, it combines the second elements. So for each row we pass in, it takes the 0th element. So this line is taken in as one list. So you can see that here. This line is taken in as another list. So you can see that here. And similarly, it has been uh, returned, right? So uh, that's what zip does. It takes in the corresponding elements in a given amount of lists and it makes a new list. So if you pass in like 5 lists, it will take the first element and make a list of all the first elements. It will make a list of all the second elements, make a list of all the third elements, and it will return it. So that's what has been done here. See, the first elements are in this list. Second elements are in this list. Third elements are in this list. So that's how zip works. And it is exactly what we need to do this matrix transform, right? So I think there's one thing to remember though. This zip, it also returns a zip object. So if I try to print this, it will show zip object. So because I'm iterating through it only, it will give give the value. So we should also convert this zip object into a list. You can see we have a uh, list of zip objects, right? So next what we have to do is we have to flip this, right? So flipping this might be a bit of a problem. So now we have the transpose matrix, right? Now we don't have to worry about this. We have the transpose matrix. So now you can see, yes. So now we have to flip this in order to rotate the matrix, right? So I think the easiest thing to do is for row in matrix. So instead of doing that, let's do I in range in print matrix I. So see, I'm putting print statements everywhere just to verify that my code is correct. So see, now it's correct. So it doesn't make a change. We'll try to change it by doing something like matrix I equals matrix I. And now remember list slicing, right? We slice the list. So I'm going to do it like this. I'm going to do it with Python. Is it like this? Smart. Yeah. So yes, so that is what I've done. What I've done is I've sliced the list and I've uh, changed it in a way. So I think if you want to understand what I did in this code, right? So I take matrix I and I need to change it. So what I do here is I'm iterating through all the whole matrix. So what this does is it takes matrix I, and matrix I is a list or it's a tuple. If I'm not mistaken, it's a tuple. And what this does is it returns a copy of the whole matrix, the whole list, the whole matrix I. So it from 0 to n, that whole length, it will return it. But I think you all may have learned that Python has this function that allows you to skip. So like if I put 2 here, if I put 1, it will give the same answer, right? But if I put 2 here, it will give me only every second term, right? And you'll also may have learned that if I put minus here, it will give me all the terms, but from back to front, right? And that is what it does here. And now you can see that matrix is rotated. Print matrix, finally print matrix, which should give us the rotated matrix. And now what we're going to do is just return this. Return matrix. So mat equals. We can remove these print statements. And now you can see. So now what all we have to do is put this for I in range. Turns equals rotate mat. So let's just take, finally, let's just print it and see. Print mat I. So range 1. Let's just try 1 rotation to see. Is the print happening? Let me move this. So yes. And now you can see, we'll just run this code to see. So this is what we input and this is what we get, right? So you can see it has rotated 1 time. And I'm pretty sure if we just change this to turns, we should get something rotated twice, which is okay. We change turns to 4. We should get the same thing back again. Just one thing to remember, the zip function returns tuples. So if you want list, you may have to make like a temporary variable, like somewhere here when you're doing this. But most of the time, like since you're outputting, you can just output each number individually by putting another for loop here and outputting each number. That you can do by yourself. I think you all know how to use the print statements like print and then with end equals like space or something like that. So I think you all can do that. So I think that solves that question. So just remember this print with the end. So you can manipulate your output using that. So I think that solves this question. Does anyone, did you guys understand? First of all, this is a bit of a tough question, but I did it using like what I feel is the optimal method. So did you guys understand? Is there anyone who would like me to explain it once again? Any questions regarding this? I'll give you a few. Yes. What would you like me to explain? Tell me what you all want me to explain, and then I'll explain it. Okay. Will marks be deducted? Uh, okay. So first of all, marks won't be deducted if you use zip, because unless they tell you don't use Python, any other Python functions except this. So for example, if they say transpose this function, uh, transpose this function by using only for loops and the input, then you have to use whatever they've said, whatever they've asked you to use. So as long as they don't say don't use any these functions or use only these functions, you can use it. That's not an issue because that's a Python function. I used it. I can't remember if I used it in a lab or in a programming problem, but I remember using zip and I didn't get any marks deducted. So zip is, as you can see, it's a cheat code, right? For transposing a matrix. Anyone can just, it's just one line and you transpose this matrix, because I remember doing this manually. It takes quite a big set of code. So uh, the zip is very useful for transposing matrix, and you can see even it became useful here. And I think the main thing that helped was understanding the pattern. So let's just go over a recap of how we solve this question. And I think someone has asked, can I share the code in the chat? Yes, definitely. I'll share the code after I'm done. Yes, so I will go to a recap. I'll go to a recap of this session, and I will go to a recap of this question. Sorry, recap this question. So if anyone has any other questions that you all would like me to solve, just let me know and we'll try to do it, because I think we can do for another half an hour maybe. So just drop a message in the chat if you all have any other interesting questions. We'll try that as well. So someone had asked, can we reverse the tuple once we create it? Yes, that's a very good question. And I think you may know that tuples are immutable, right? That's a special characteristic of tuples, is that tuples are irreversible, right? You can't change, not irreversible, it's immutable, which means you cannot change the tuple. So for example, if you take this matrix I tuple, which we get here, we can't modify it, right? But what I've done here, when you do this list, when you do this slicing operation, right? You're not changing it. What you're doing is you're getting a new copy. You're getting a new copy of this same tuple, right? And here, I think you may notice if I do this, right? If I do this, you can see, sorry, you can notice, what's happening. Yeah. So I'm calling, y'all can see I'm calling, because I'm calling that function many times, it appears many times, but it. So you can see what zip returns. Here, what we are doing is we are getting a list of tuples, because although the rows in the matrix are tuples, what we convert the whole matrix, the matrix object, it is a list, because here we whatever the zip object returns, we convert it into a list, right? So because of that, uh, um, this whole matrix is a list of tuples. So we can modify the individual rows, because the rows, although what is in the row is a tuple, the matrix is a list, right? So we can modify the matrix. We can change the whole rows inside the matrix, but we can't change what's inside the rows because those are tuples. But the whole matrix is a list. So it's a list of tuples. So we can modify the list, but we can't modify the tuples. I hope you understood what I'm trying to say. It's a bit confusing, right? So we can change the matrix. So we can like get an element in the matrix and assign something new because that's a list. But we can't go do something like this. Matrix I 0 equals 1. We can't do this because we are trying to access a tuple. But when we do matrix I, what we are accessing is the list. We are trying to change the list. So I hope you understand. If you did, just raise your hand. If you didn't, maybe you can drop a message. Right? Did anyone? So what you can understand here is what I'm doing is I'm getting a new copy of the tuple, which is reversed. I'm getting a copy of the tuple, which is reversed, and assigning it to the matrix. So that's how I have solved this question. Also, y'all don't have to call me sir. I'm just 1 year older than you guys. So just y'all can call me Aya. Uh, so yeah, I think y'all understood this. So it's what this slicing does is we get a copy and we assign it to the current existing row. So now let's go through a quick recap of what we did in this question. We took the input, right? And we saved a empty list as a matrix, and we took the input and saved it into matrix, right? Next, what we thought was instead of rotating it n number of times directly, we make a function to rotate it one time, and we take a function to rotate it one time and call that function n number of times. So that simplifies our code a bit more because we are doing one thing once and we are calling it n number of times. So because of that, we have this function where for I in range turns, we call this rotate function, right? And then we go to the rotate function. So what we figured out was first a shortcut to do this rotate. And we figured out that first I was thinking first what I was thinking was what is similar to this rotate, right? And then I realized that this transpose, when you transpose the matrix, it is kind of similar. It is very close to what we get when we rotate, right? And only thing we have to do is reverse the columns in the transpose matrix. So then what we went to is, okay, we are going to transpose the matrix. So that is what we did here. And if you all understood, what we do in transpose is this. Transpose is this. Where am I printing? So there's a lot of print statements. I'm trying to figure out. So if you all can remember, so when you get this, right? When you get this list of lists, right? And when you pass it into the zip, what the zip does is it makes lists of each position of the element. So it makes a list of zeroth elements, which is this. So 1, 5, 9, 13. Next, it makes a list of two first elements, which is 2, 6, 10, 14, and then third elements and fourth elements. So that's what zip does. And what we realized is that the zip is just the transpose function. So one thing I reminded you all is zip returns a zip object similar to map. Map also returns a map object, and we have to convert it into a list. So here from this, we have a zipped, a transpose matrix. Next, what we have to do is uh, we have to reverse this transpose matrix, because see, this should come here, right? And that is what we did in this part of the code. We iterated each row. So each row is a tuple, but this matrix is a list of tuples. So we can modify the whole row. The row as a whole, we can change. So row one, we can swap with a new row. We can put a new row to row one, but we can't change inside. So what I did here was I made a copy of the current row. So I iterate for every row I'm iterating. I make a copy of this row, right? And then I, using this -1, which is the third argument in this tuple slicing, I reversed it. So, and then I assigned it to the current row. So there I get a rotated matrix, right? So, and then I return it and I assign it to the old matrix, and I do that, uh, that the number of times specified in turns, and I finally get a rotated matrix, right? So I hope it is clear. Are there any more clarifications? If you all got it, just drop me a message saying got it. If not, just ask me any questions. So spiral matrix, yes. I will find the code and send you the code for spiral matrix. I feel like it might take a bit of time if I go to explain and do spiral matrix at the moment. Uh, but the way I remember, I'll try to give you a small hint for the spiral matrix. Uh, what I did was I used a recursive solution for spiral matrix. So if you all can use this hint and maybe try it. What I did was I used a recursive solution in the sense, first my base case was the middle part, right? So because the middle part will be like 1, 2, 3, or something like that. So that was my base case. And then, so with the base case, so if I had the big thing, what I would do is I would fill the outer row and then keep on filling the middle row and finally return. So you can do it either way, either get the recursive part of the inner middle part and then finally fill the outer row. Or you can fill the outer row, then go to the recursive function and call the inner row, not inner row, but inner matrix. Like, so the first, how do you say? So if it's a 4 by 4 matrix, the first column, last column, first row and last row was the first recursive, like first big part. And then I went in to the inner part, like which would be a 3 by 3 matrix. No, sorry, which would be a 2 by 2 matrix. And then once it's a 2 by 2 matrix, you can't go any deeper. So that's how we did that. I had to and then I had to consider two situations where, like, if it was like a odd number, then it's different, because then the base case is a single digit. If it's an even number, the base case would be a 2 by 2 matrix. So I use that thinking pattern, and I did that. This matrix can also, the recursive solution was much easier. So yes, I will see if I can find any more problems. like the matrix one. Does anyone have any other questions which are like not matrix, maybe something like a string manipulation or a calculation problem? Are there any questions like that? So yes, I will send you more questions. Spiral matrix. I will send you the code that I did, but I think use the idea that I gave you all and try to do it by yourselves. Uh, this code I will put in the chat. Is there anything else? So I think I went through the zip function. I went through the map function. Just remember to convert them into a list after you're done. Uh, so I think someone had asked about lambda functions. So lambda function is like, it's nothing big. Just use to highlight it. So for example, let's have a lambda function x equals where is lambda a. Yes, this is how it works. So what this lambda function is, it's like a one line, it's a small function, right? So which takes in, so we are saying lambda a, so the input is a, right? And we put this colon to say, okay, now we've taken the input, this is the function body, and the function body is just a plus 1. So for everything you add a plus 1. So let's say x equals this, and this, and finally print. So you can pass in to this lambda function, you can pass in a iterable. So it will do everything. It's something like map, right? So when you pass in, like you you can't sorry, you can't pass in an iterable, but you can use it with something like a map, right? Because if you put, so now remember what I was telling, map, what it does, it takes some list or a tuple or something that you can iterate and does the function to every single element. So let's think we have this list, right? We have this list and we want to add 10 to every single element, right? So we can do that with a map function. Map. And then, so what is the function that we are doing? The function that we are doing is x. And to what are we doing it? We are doing it to list. So what we should expect is everything added by 10, 10 added to everything. But remember, map returns a map object. We should convert this into a list. So you can see lambda has added 10 to everything. So you also remember you can do this, you can do tuple here. So so what lambda does is it's like a small placeholder function. It's you can just pass it in. I mean, you don't have to define a lambda function. I think even something like this should work. But lambda function, you can, the trick of the lambda function is you can put it here as well. So you can see there's no change. You can put a lambda function inside here instead of defining it somewhere else and using it. So lambda function, you can like just pass it in without defining a function. For example, these are useful in instances where you don't want to like have like save the function, because now, for example, if you define a function, it will get saved and you can call it later. But what if you just want this x function only for this map? Then you can remove it from here and just put it here and you will have the answer. So see, the code is very simple. You can see what this map does. So map does a plus 10 to every item in list, right? So it is something like that. So I hope you all understood what lambda functions were. Uh, did everyone understand? Are there any questions regarding lambda functions? Uh, are there no questions? Mm, okay, so I think there are no questions regarding the lambda function. So let's go on to another concept which someone had asked me, which was the complement function in Python. Uh, so I think what you're talking about is like, let's think n equals 5 print n. So n will give you 5. I think you're talking about when you do this, right? Yes. Uh, I think that was the question that someone had asked me. How does complement work in Python? And that is something that you will learn in the next part of your programming fundamentals course, which is how a number is complemented. So I will just give you a brief example. So let's think n equals 5. Print. So I think you may have heard of the binary function, which is this. And print binary this n. So what this does is it complements, it flips all the bits in the binary value. So if you check this here, so we'll ignore. So this is what you have to worry about, right? These parts are just, it's just saying it's binary, and this part is just saying it's negative. Or the problem is this is in 2's complement. So I can't really show you how do I show this to? Mm. Still not sure. Come and so what binary does, what do you call the complement function does is it flips all the bits. So what you might see is this, when you check the binary of this, it gives 1 0 1. But what the binary of like complement n will give you a different value. So that is done with how Python is written. So uh, uh, when you take in how Python is stored in Python, like an integer in Python is stored Python. I think it has 4 bytes, so it's like 32 bits. So uh, let's see. N will be some in Python's memory. It will be like something like 0 0 0 0 0 0 0, and it will be something like this, right? But n so n flipped is something like this, right? So this, when you put it into a decimal, int this, oh no, wait, sorry. Yes. What are you trying to decimal? Decimal in Python would give you -6. Yes, so I think what we can do is int and base 2 base equals 2, and I think this should give you I think I'm making a small mistake here because I think this is not 32 bits. So yeah, that's the issue which I'm making here. So if this was 32 bits, this is I think 4, 6, 8. Yes, so I think there's a small problem here, but what you learn about this in towards the end of your Python programming course. It is basically just complementing, right? It's taking the complement of 5, so it's just flipping all the bits. So if you have something like this, you will get something like this. So that is what complement does. Uh, Yes, so I will definitely send you this matrix code. I'll send you this notebook by itself. So y'all can just get an idea of how it works. So I will send you the code for now. If you all just want it for now, I'll just put it in the chat just so everyone has it. So are there any questions? So I think we can wrap up now. Are there any questions that you would like to ask? Anyone? Hmm. Seems like there are no questions. I'll just give you another 5 minutes. So if you all want, you all can ask any questions. If you all have any other topics, yes, I think some of you all wanted the doing calculating the determinant using uh, calculating the determinant using recursion. So shall we try that? Matrix. Yeah. So I will not take the input here. Let's just try to do this just what do you call it? Recursively. So the issue we will come across when we are doing this recursively is we'll have to build new matrices, right? Because when we are taking this part, right? Uh, when we are taking, like, we'll have to select, okay, let's take this row. So we'll have this row, so 1 into the determinant of this, 2 into the determinant of this and this, 3 into the determinant of this and this, right? So the issue we will have is figuring out how to make this new matrix. So we should be able to solve it. So okay. We would have it, what is so yes, let's try not to look at this the code which is recommended, but what I was saying was uh, the base of so we'll just start with the 3 by 3 matrix. So the base case of a determinant is what we learned for A levels, right? Uh, the base case of find the determinant is uh, the base case of finding the determinant is a 2 by 2 matrix, right? So it is this, right? So let's first code the base case. I think this will give us the code, but let's just go through individually. So if length of matrix is 2, so what they're trying to do is they're trying to say, okay, if this is a 2 by 2 matrix, then we know we have come to a base case, and we can do this into this minus this into this, right? So the base case is set. So now what we have to figure out is how to break this down, right? And again, I feel like ChatGPT will give us, GitHub Copilot will give us the answer. But I think it's important to understand like how we will code this. So what we'll take this as that deciding row, right? So this into this into this. So I think you may realize. So let's think we iterate over, or what would be what would be easier to iterate over. So if we iterate over this, you can see what we are taking. So this one's the, what do you call it? Uh, the index, when we are iterating, this one's index will be 0. So we take everything that is in the columns that are columns and rows that are not 0. So we take the first columns stuff, the second column stuff, second row, second column. So we probably can figure out a relationship to making the new matrix from that idea, right? Just remember that if we take, like if you are multiplying it by the ith value, so I into this ith value, we take everything that's not in its column and its row. So we can see here, so 0 column, 0th value is multiplied by everything that's not in the 0th row and 0th column. And then if we take this, it is the 0 row, but first column. So 0, 1, right? So then we take everything that is in, that is not in the 0 row and first column. So that is these two. So I think this, what was the completion gave was correct. So we first set the determinant to 0, and we iterate. So we iterate either this way or we can iterate this way, right? And so to the determinant, we add -1 to the power 1, I. So because if I is 0, it's positive. But if I is like 1 or 3 or something like that, it will be negative. So it's like, that's how it works. So, and here, what the code that they've given, we are going to uh, use the values in the first row. So we are doing 1 into this, 2 into this, and 3 into this, right? And so that is multiplied by the determinant of the smaller case, which is this. So building that is going to be the next question. So here they have a nice explanation of how they're doing it. So first thing to remember is we are taking this as a what do you call the defining row? Like I can't remember what the name for it was. We are taking this as the main row. So we have to pass in, like whatever we pass in will not be from this main row. So we will iterate, we will pass in these two rows. So that's what they're doing here. For row in matrix, not included in this. So we are iterating everything that is not included in the first zeroth row, right? And within that, for every I, so remember this I is the base case, right? We are iterating from that I, we are iterating this, this, and this. So for every I, what we do is row everything up to this I. So if it's 0, 0 to 0, so that will be nothing. Plus row I plus 1 till the end. That is 0 plus 1 till the end is 1 till the end. So all of this. So you can see this is the inner loop and this is the outer loop. So for every row, we find the determinant of this. Then for the second, so that is for, let's take for example, if I is 1, the determinant is minus 1 to the power, so sorry, if I is 0, so minus 1 to the power I, which is 1 minus 1 to the power 0 into matrix 0, 0. So that is into this. So 1 into the determinant of this 5, 6, 8, 9. So I think that is, so similarly, if we go to 2, minus 1 to the power 1 is minus 1. And then this will give us 2. This part, we'll first iterate for each row. It will take this and make it into a list. And this and make it into a list and find the determinant of that. And that all of these will be added to this determinant we defined here. So you can see this is done recursively. And we can do a small experiment to see, like, let's take a 4x4 matrix. And before we exit, we'll print the determinant. So typically, this should get called, this should be printed 4 times, if I'm not mistaken. Why don't we go to this? What happens here? Ah. So, what's happening? Yes. So, okay, this code has a small issue because you have to return the determinant. So that was not doing that before. So always remember, you may encounter a small bug in your code like that because we returned in the base case, but we didn't return in the normal case where we divide, right? So always remember to return the determinant, and I think should be fine. Print. So still I'm having a small issue. Can anyone, if you all also see if there's an issue, just let me know. I'm also trying to figure out where this issue is. The determinant. Yeah, this shouldn't have an issue. Ah, did anyone see the issue? It's a very, very silly mistake. Ah. Can anyone point out this main code? What's the main issue? Ah, stuff like this happen. Yes, very good. Pabasara. Yes. I haven't called the function. So I've coded the function, but I haven't called it. So that happens. So try to avoid stuff like this. We're having another issue, which is That's happening. Print matrix. So see, this is the issue, or this is the problem that you get when you don't uh, uh, put what do you call print statements and check your code. So you can see it's getting printed here, and then the smaller case is getting printed. The smaller case. There. Then finally, what we should do is return it. Oh, yes. Uh, yeah, this is a bit of an issue. What have I done wrong? Can anyone point out to the issue? Mm, where is this? Where am I going wrong here? So 11 into 20, 11 into 12 is how much? 132. 15 into 16 is 60. 240. 11 into 16. 11 into 16, 176. 15 into 12. 1, 12, 180. This is -4. This is correct. This is -4. This is correct. This is -4. This is also correct. Why does this become 8? Parenthesis. You are saying to try doing this. Will this change? Doesn't make a difference. What is the issue? -4 plus -8. That's happening. Wait, don't know if it is because of the way I've put this. Let's check that. Don't know if the determinant of this is 0. No, that's not the issue also. There's a small issue in this code. What have I missed? If y'all also see the issue, just y'all also can try this. Is the determinant 0? Oh, interesting. It's not giving the final. Not giving it. See what happens here. Still 0. What's the issue? Let's try a 3x3 matrix. What happened there? Just can someone check and tell me if the determinant of this is also 0? So the answer will be -3 into 1 is -3. This will be 12. This will be -9. Yeah, it's 0. Let's change this to like 1. Let's see. Why is everything 0? Okay, it works. Yeah, I think the issue was that I was doing the calculation for uh, matrices where the determinant was 0. So I think now the code works. So let's see, minus 39. Let's just make all of these ones for ease. And I think the issue should be solved, no? 5. Yes. Shit. So minus 39 would be the determinant of this. 1 into minus 48. 9 into minus 48 is minus 39. 36 into minus 42 is minus 6. That's correct. 42 into minus 7 is, sorry, 32 into minus 7 is 25. So minus 39 plus 6, which is minus 33 plus 25. Yes, correct. So I think this also is solved. I had to unfortunately use a bit of GitHub Copilot. I will send you all the code in the group, but I think we can end for today, unless you all have any other questions. Again, it's just about figuring out the pattern. So I think the best process when you are following the PP, PP2 would be read the question, look at the input output, try to get a pattern, read the question once more, and then immediately start taking the inputs, because while you're taking the inputs, you can think of the answer, think of the pattern or think of a solution, because you have time. So while you're taking the inputs, you can, in your mind, think about what the answer is. Once you've got the inputs, keep taking the inputs like by putting print statements. Once you got the inputs, if you still haven't, then you have to just spend some time and figure out the answer. So I think this should be all. We'll do another session where we'll discuss some more PPs So send me the PPs which you all find difficult. I think the permutations and combinations one was a bit tough. So I'll try to explain that uh, in the next session. And we'll also do sorting algorithms. I'll send you all a few videos. Watch those videos regarding sorting algorithms. So you all will have a better idea when you all are doing these sorting algorithms. So yeah, I think that's about it. If you all have any questions, you all can ask. If not, we can end the session. So thank you for joining. Thank you guys for asking questions also. So yes, that is it from my end. Any questions?
Uh, Thanks a lot for the session over there.
No, anytime. If you all need any help, you all can drop me a WhatsApp message and I will help in any way possible. So
Recording stopped.